Welcome back to a brand new unit. All right, so we are on Unit 5, and this is all about systems of equations and inequalities. We are going to be learning 3 different types of how to solve a systems of equations. First of all, you need to know what a system is. So a systems of equations is two, I didn't spell two right, 2 or more equations with the same variable. So there are 3 ways we're going to solve systems of equations, 3 of them. One is graphing, one is substitution, and one is elimination. Today we are going to be learning all about how to solve them by graphing. So many different ways to solve them. You need to know all 3. So the first one we're going to do is graphing. So when you talk about a solution to a systems of equations, all that means graphically is that when you graph your 2 lines, we've been doing linear equations last unit, so when we graph our lines, it's the point at which they intersect. That's the solution, because when you have intersecting lines, your x and y value are exactly the same. So it is at that point where the x and y value are the same, that's the solution. So when you have intersecting lines, there's only one solution, and it is literally at that point. When you have parallel lines on a graph, how many times do those lines intersect? None. So there are no solutions. No solution. When you have the same line, so let's say we graph the line and you graph the same one on top, how many solutions are there? Infinitely many solutions, because it is every single point that they have in common. So when we talk about the solution, graphically, it is the point where the 2 lines intersect. And algebraically, it is the point xy that makes both equations true, because that's equality. So that's what it looks like, that's what it means. And I'm going to give you the steps for solving them graphically. All right, so we already know how to graph lines, right? The first thing we do when we solve systems by graphing, step 1, is we need to put both equations into slope-intercept form. Put both equations into y equals mx plus b form, slope-intercept form. Step 2 is we graph them. Graph the line. And step 3 is we are going to identify the solution. Now, remember, while you're watching this video, write in your journal, because if you write in your journal everything for this unit, then you get to use it on a quiz. So let's look at number 1. And I'm going to graph the first one in blue, and I'll put a mark that means that's the color that I'm looking at. So my intercept is -8, so I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. Oh, I'm way off. Let me calibrate this. Sorry, guys. On this unit, you are still using a ruler, a straight edge. You are still going all the way through the graph, and arrows on both ends. So I don't need to tell you that again, because I'm sure you remember that from last unit. So here we go, 2, 4, 6, 8, and my slope is +1, so I go up 1 over 1. So that's what my line's going to look like. Yours is going to be better. And then in green, I'll graph that one. My beginning point's 1, and my slope is down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And when I graph that, I can look, and where do they intersect? It is at this point. So that coordinate point is x is 3, my y value is 3, 4, -5. Okay? And if I want to check my answer, so that's graphically. Algebraically, what that looks like when you have one solution is that this 3, -5, if I plug in 3 and -5 for here, so notice, here's my first equation. -5 is y, so -5 equals, my x value is 3, 3 minus 8, and -5 equals -5. That one checks out. So I know that this point right here is absolutely on that line of blue, because I just checked that they equal each other. Now let's see if the second line matches. So my second line, I'll write that one in green. Y equals negative 2x plus 1. If I plug in these values here, it better match 2. So negative 5 equals negative 2 times 3 plus 1. Negative 5 equals negative 6 plus 1. Negative 5 equals negative 5. It checks out too. So I can check my answers on these by plugging them back in. So that is algebraically. So on those notes up there that we wrote, that's what it means by algebraically, using algebra. Okay, so let's do a few more for your journal. So let's go down here. I'm going to expand. Let's go to 200. And let's look at number 3. So it's in standard form. So step 1 said let's change it into y equals mx plus b form. So I'm going to take my first equation and add 3x to both sides, and I get y equals 3x plus 8. So now my slope is 3, my beginning point is 8, and I can graph that. My beginning point is 8, 2, 4, 6, 8. Slope is up 3 over 1. Uh-oh, it goes off the chart. So what do? I can reverse that process from my beginning point. Now I'm going to go down 3, run the opposite way 1. Down 3, run the opposite way 1. Down 3. So that's where I get my line. Okay. And now my second one, negative x plus y equals negative 2. I'm going to add x to both sides. Y equals x minus 2. So now my slope is 1. My beginning point is negative 2. And when I graph them, here's negative 2. My slope is up 1 over 1, up 1 over 1. Right there. So it is at that point of intersection. So it is negative 4. 1, 2, 3, 4, 5. Negative 5. So that's what I should be getting there. Okay. All right, let's take a look at, let's take a look at number 5. So on this first one, x plus 3y equals negative 15. I need to get it y equals mx plus b form, so subtract x on both sides. 3y equals negative x minus 15. Divide everything by 3, and I get y equals negative 1/3 x minus 5. So when I graph it, here's negative 5 is my beginning point. My slope is negative 1/3, so now I'm going to go down 1, run 3, down 1, run 3, down 1, run 3. And then I'm going to reverse it. So that's what my line looks like. And then remember this special case of graphing a y equals negative 7. I know my beginning point's negative 7 and a 0 slope. So that's what this line looks like. And do they intersect? They do. They intersect at this point. So it's 3, 6, negative 7. So hopefully you guys get the feeling of how to graph and what happens when you graph. Let's do, let's do number 6. So y equals x plus 5. My beginning point is 5, 3, 4, 5. My slope is up 1 over 1, up 1 over 1. So that's what my line looks like. And on this one, I'm going to subtract x on both sides. I get negative y equals negative x plus 2. And now I'm going to divide everything by a negative 1, which makes it y equals x minus 2. So here's negative 2, up 1 over 1, up 1 over 1, up 1 over 1. Now, I already know that my slopes are the same. So what do you know about the same slope? Parallel lines. So how many times do these lines intersect? They don't. So there is no solution. No solution. Got it? All right. So that should help you with graphing systems of equations by graphing. That's video 1. Good luck.